Today, we will solve this problem from Jee Adv 2019. This is an interesting problem. You must attempt this problem one time before watching the solution. Actually, what is given in the problem, fn is equal to this for non-negative integers n1. Okay. So, we need to simplify this fn first. Then, we need to check for the correct options. This is a multi-correct option type problem. That means one or more options can be correct. So let's start. So I have written this fn in the next page here. We need to simplify this first. Okay. So to do it, first what we will do, we will multiply and divide by 2. Okay, we will multiply and divide by 2. So if we do it here, it will be 2 and here it will be a 2. Okay. So now we can move this 2 inside the summation sign and also you can move this 2 inside the summation sign. Okay. So when I did it, you can see that here it is like 2 sin A into sin B form, right? It is like 2 sin A into sin B. So we know that 2 sin A into sin B is equal to cos of A minus B minus cos of A plus B, right? So we will use this formula here. So in the numerator here it will be summation k equal to 0 to n cos of a minus b. Here a minus b will be k plus 1 minus k minus 2. So that will be actually minus pi upon n plus 2, right? Minus cos of a plus b. So here a plus b will be 2k plus 3 upon n plus 2 into pi, right? Okay. Divided by, in the denominator, here it is summation k equal to 0 to n. Now here it is 2 sine squared theta form, right? 2 sine squared theta form. So we know that 2 sine squared theta is equal to 1 minus cos 2 theta. So we will use this formula there. So here it will be 1 minus cos 2k plus 2 upon n plus 2 into pi, right? Now what we will do, we will break these summation signs. Before that, here it is cos minus pi upon n plus 2. So cos minus theta is equal to cos theta, so we can remove that minus here. Okay. Now we will break the summation sign in the numerator and the denominator. Okay. So if we do it here in the numerator, it will be summation k equal to 0 to n cos of pi upon n plus 2 minus summation k equal to 0 to n cos of 2k plus 3 upon n plus 2 into pi. Okay. Divided by, here in a denominator it will be summation k equal to 0 to n 1 minus summation k equal to 0 to n cos of 2k plus 2 upon n plus 2 into pi, right? Now you can see that cos pi upon n plus 2, it is a constant term, right? So if I ask you how many terms are there from k equals 0 to n, you will say that there are n plus 1 terms. So we can simply n plus 1 into cos pi upon n plus 2, right? We can simply write this. So then here we need to simplify for this. So I am keeping it as it is for now. So this is summation k equals 0 to n cos of 2k plus 3 upon n plus 2 into pi. Okay. Divided by, now 1 is a constant. So how many terms are there from k equals 0 to n? There are n plus 1 terms, right? Minus, here it is summation k equal to 0 to n cos of 2k plus 2 upon n plus 2 into pi. Okay. Now we need to simplify for these two. Okay. So let's do it. We will simplify one by one. So first we will simplify for this. So actually that is summation k equal to 0 to n cos of 2k plus 3 upon n plus 2. So first we will expand this. Okay. So if we do it here, it will be cos of, when we will put k equal to 0 here, we will get cos 3 pi upon n plus 2. Okay, plus cos. Now, if we put k equal to 1 here, we will get cos 5 pi upon n plus 2. Okay, plus if we put k equal to 2 here, we will get cos 7 pi upon n plus 2. Okay, so this will continue to, when we will put k equal to n, we will get cos 2n plus 3 upon n plus 2 into pi. Okay, so now you can see that the angles here are in AP series, right? Where the common difference is 2 pi upon n plus 2. So for this type of cosine series, we know a formula. Let me write it here. So that formula is actually, if there is some series like cos theta plus cos of theta plus alpha plus cos of theta plus 2 alpha, this will continue to cos of theta plus n minus 1 into alpha. How many terms are there total? There are total n terms. Okay, so we can write this series as sine n alpha by 2. Alpha is the common difference in this series. Okay, common difference of the angles, divided by sine of alpha by 2 into cos of, here it is theta plus n minus 1 into alpha by 2. That is the formula. You know that, I guess. If you don't know this, remember this. This is an important formula. Okay, so we will use that formula here. Now here, if I compare these two, here theta is equal to actually 3 pi upon n plus 2, right? Alpha is equal to 2 pi upon n plus 2. Okay, and here the total numbers of term is n. So here n is equal to actually n plus 1, right? Here n plus 1 total terms. Okay, so now if we apply that formula for this will be sine n plus 1, sine n plus 1. Now here the common difference is 2 pi into 2 pi upon n plus 2, right? Whole divided by 2, whole divided by sine of 2 pi upon n plus 2 whole divided by 2 into cos of, here it is, now theta is equal to this here, so this will 3 pi upon n plus 2 plus, now what was here? It was n minus 1 here. So here n is equal to n plus 1. So here it will be n into, there was alpha by 2. So this will be 2 pi upon n plus 2 whole divided by 2, right? So now you can simplify this easily. This and this will be cancelled out. Okay, these 2 and these 2 will be cancelled out. Here also these 2 and these 2 will be cancelled out. Now in the numerator here, you can get sine n plus 1 into pi divided by n plus 2. So you can write that as sine pi minus pi upon n plus 2. You can check easily. Divided by, here it is sine pi upon n plus 2 simply. Okay, into cos of, now here it is 3 pi upon n plus 2 plus n pi upon n plus 2. So that is actually n plus 3 whole into pi upon n plus 2. So you can write that as pi plus pi upon n plus 2. Okay. So now sine pi minus theta is equal to sine theta. So here sine pi minus pi upon n plus 2 will be equal to sine pi upon n plus 2. So this and this term will be cancelled out. And cos pi plus theta is equal to minus cos theta, right? So this will be minus cos pi upon n plus 2. So we simplified the first one, okay? Which we will put in this place. Clear? Now into simplify for the second series. Let's do it. So the second one is summation k equal to 0 to n cos of 2k plus 2 upon n plus 2 into pi. I guess that was that. Yeah. Now to simplify for this, same, we will first expand it. So if we expand it, it will be, when we will put k equal to 0 here, we will get cos 2 pi upon n plus 2, right? Plus cos, when we will put k equal to 1 here, we will get cos 4 pi upon n plus 2. Okay. plus cos. When we will put equal to 2 here, we will get cos 6 pi upon n plus 2. So this will continue to, when we will put k equal to n here, we will get cos 2n plus 2 upon n plus 2 into pi. Okay, here you can see that also the angles are in AP series, but the common difference here, it is 2 pi upon n plus 2. So now we can easily compare this with this one, right? We can easily compare this with this one. So here theta is equal to 2 pi upon n plus 2, right? Alpha is also equal to, the common difference is also equal to 2 pi upon n plus 2. You can see easily. Okay. Now an is equal to n plus 1 for here also. Clear? So now we will apply that formula for this. So this will be sine n plus 1 into, now alpha is equal to this, so this will 2 pi upon n plus 2, okay, whole divided by 2, whole divided by, it will be sine 2 pi upon n plus 2 whole divided by 2 into cos, now theta is equal to here 2 pi upon n plus 2, right? Plus, now here n is equal to n plus 1. So there was n minus 1, right? There was n minus 1 here. So here it will be n into 2 pi upon n plus 2 whole divided by 2, right? So now you can see that 2 and 2 will be cancelled out. These 2 and these 2 will be cancelled out. These 2 and these 2 will be cancelled out. Now here, what will be left? See carefully that here it is n plus 1 into pi divided by n plus 2. So that can be written as sine pi minus sine pi minus, here it is pi upon n plus 2, right? Whole divided by, here you can see that it will be sine pi upon n plus 2, okay, into, here it is cos. Now here you can see that it is n plus 2 whole into pi divided by n plus 2. So n plus 2 and n plus 2 will be cancelled out, and what will be left? Cos pi will be left. So now here it is sine pi minus theta again. So that will be sine theta. So this and this term will be cancelled out again. So here it will be cos pi only left here. So cos pi is equal to minus 1, right? So we simplified this and got minus 1. Okay. Now we have to put these values in our here. Okay. So I am going upwards from here. Okay. So this will be n plus 1 cos pi upon n plus 2 minus, here what we got? We got minus cos pi upon n plus 2. So this will be plus here, and this will be cos pi upon n plus 2, right? Whole divided by, here it is n plus 1 minus, what we got here? We got minus 1. So this minus and minus will be plus 1. Okay. Now here, if we take cos pi upon n plus 2 common, we will get n plus 2 in the bracket, and here we are getting n plus 2 again. So n plus 2 and n plus 2 will be cancelled out, and what will be left? Cos pi upon n plus 2 will be left after solve. So we simplified this and got cos pi upon n plus 2. I am writing clearly here. So this is equal to actually cos pi upon n plus 2. Okay. We will use this only. So now we need to check for the options. So what we got? Fn is equal to, actually Fn is equal to cos pi upon n plus 2. So first what we will do? We will put n equal to 4. So if we do it, it will be F4 equal to, F4 will be equal to cos pi by 6. So cos pi by 6 is equal to, root 3 by 2, right? So this is correct option. Okay. We check the first one, and that is correct here. Okay. Now we will check for the second option. Second one is limit n tends to infinite, fn is equal to cos pi upon n plus 2, right? So now if n is tending to infinity, then n plus 2 will also tend to infinity. So this will be actually pi upon infinity. So that will be equal to 0. So after solving the limit, what we will get? We will get cos 0, which is equal to 1. So this option is wrong. Okay. So second option is wrong. Now let's check for the third one. Okay. Now here we need to find alpha. Alpha is equal to actually 10 of cos inverse f of 6. Right. So f of n is equal to cos pi upon n plus 2. Right. We got it. So this will be 10 cos inverse cos of. Now if we put n equal to 6 here, we will get cos of pi by 8, right? So this will be actually 10 pi by 8. Okay. Now 10 pi by 8 is actually tan 22.5 degrees. You need to remember these values directly. This is root 2 minus 1. Okay. If you don't remember, I am not solving that in this video. You can try to solve it using tan 2 theta equal to 2 tan theta upon 1 minus tan square theta. Just put theta equal to 22.5 degrees. Okay. Put it and you will get after solving that quadratic. Okay. So I am not solving it here. And also you need to remember these values directly. Okay. So what we got? Alpha equal to root 2 minus 1. Now if you square both sides, we will get alpha squared. Okay. Do one thing. First we will bring this minus 1 to the left hand side. Okay. Equal to root 2. Now we will square both sides. So this will be alpha squared plus 2 alpha plus 1 equal to 2, right? So from here you can say that alpha squared plus 2 alpha minus 1 equal to 0, right? So this option is correct. I hope that is clear. Now we need to check for the last option. Okay, we need to check for the last option. Let's do it. So here I am writing fn here. So this is cos pi upon n plus 2. So what is given? Sine of 7 cos inverse f of 5, right? So what we will do? So this is sine 7 cos inverse cos of, when we will put n equal to 5, we will get pi by 7, right? So now cos inverse cos pi by 7, so that is equal to 7 into pi by 7. That will say, this will be pi by 7, so this will be 7 into pi by 7. So this and this 7 and this 1 will be cancelled, and what will be left? Sine pi will be left here. Now sine pi is equal to 0, right? So this option is also correct, right? So you can see we solved it where A, C and D are correct. Okay, A, C and D are correct and D is incorrect option. So this type of problems are important in Jee Advanced. Okay, you should do this type of problems. So if you like this video, make sure to like, comment and share and subscribe to our channel for more amazing videos and concepts. Thank you for watching the video, and if there is any doubt about the question, you can simply ask in the comment section. Thank you for giving your time.